Commercial AI agents can read your files and run code, but to do that they have to upload your private folders to their cloud servers. Today we're setting up llama-agent. It's a free open source AI agent that runs entirely on your own hardware. I've covered local agents like Hermes and Nanobot before, but llama-agent is built directly on Llama C++, meaning it just works right away with nothing else to run. It can read your file system, rewrite documents, and execute shell commands, meaning it can actually type and run terminal instructions for you. Because everything processed locally, there is no network data leaving your computer. Your files stay private. Before we look at a few examples, here is a quick overview of what this actually is. Setting up local AI usually means installing Python, Node.js, and managing complex dependencies. Llama-agent is different. It's just one single file. You download it and it runs. There is no web dashboard. You run it directly in your terminal. But even though it's a command line tool, it can still read and analyze images. It also has a built-in agent loop. That means it can formulate a plan, run a tool, read the result, and decide its next step automatically. Giving an AI access to your system sounds dangerous, but by default it uses a strict permission system. It stops and asks for your approval before it executes any command or edits a file. Nothing happens until you type yes. Let's see it in action. Example number 1. The downloads organizer. Look at this test folder. It's filled with nearly 80 random files, code scripts, archives, logs, and images. I will open llama-agent and type this exact prompt. My folder is an absolute mess with over 60 files. Create 5 folders, documents, images, code, logs, videos, and archives. Move every single file in this directory into its correct folder based on its extension. Don't leave anything behind. The agent reads the request and writes the shell commands to create the folders and sort the files. It pauses for permission, then I just press Y to accept. Then the commands execute instantly. To check it, I will run the tree command. Every file is sorted into the correct category, leaving the main directory completely clean. Example number 2. The blind bulk renamer. I have a folder full of generic files. Normally you have to open and read each one manually to know what it is. Instead, I will give llama-agent this prompt. Read all the files in this directory, figure out what each one is about based on its content, and rename them to highly descriptive professional file names using underscores. You can watch the agent loop through the task on its own. It uses its built-in read tool to scan the file, process the context, and writes a rename command. It repeats this for every file while I just press Y to approve. I will run ls, and every file now has a clear, accurate name based on the actual text inside. If you don't like the result, you can just ask the agent to undo it. I type undo what you just did, and it automatically reverts to the folder back to the original names. I will run the prompt again, but this time I'll tell it to make the file name sarcastic. 3-word summaries. It rereads the documents and outputs sarcastic names. It actively comprehends the text on the fly. Okay, so to run this, your system needs at least 8 GB of RAM to load the AI model into memory and 30 GB of storage. I'm running this on NVIDIA machine with 8 GB of VRAM. It also works on AMD or just your CPU, and the written guide has specific paths for every hardware setup. I will install this on Linux Mint. The exact commands for Arch and Fedora are in the guide in the description. Before starting, you need your graphics card drivers and toolkits installed, like the CUDA toolkit for NVIDIA or ROCm for AMD. The guide covers how to set those up too. Let's start. First, open your terminal and run this update command. Next, run this install command to get all the build dependencies, including CMake and Clang. Now run this cd command to go to your home folder. Then run this git clone command to download the repository. Run this cd command to go inside the folder. Because the software updates constantly, we need to pull a stable version. Run git fetch --tag. Then run this git checkout command. This automatically finds and downloads the latest stable release, so your build does not break. Now we configure the build. Run this CMake command. I'm using the CPU flags for this virtual machine, but the written guide has the exact commands for NVIDIA and AMD setups. Next, run this CMake build command to compile the software software. This takes about 5 to 10 minutes. Once it finishes, run this export command to add it to your system path. This lets you run the agent from any folder on your computer. The agent reads and writes files in the folder where you started. Run this make directory command to create an empty test folder and run the cd command to go inside it. Now run the llama-agent command followed by -hf and your chosen model. Because I'm inside VM, I will run the small Quen model just to verify the installation works. The first time you run this, it downloads the model file. Once you see the prompt, the setup is successful. To run the vision models, I am switching over to my main machine with RTX 4060. Here I'm running the Gemma 4 E4B model. I'm also adding -C16K to set the context window. You can increase this number if you need the agent to remember more files at once, or lower it if your system slows down. I use 16K for my examples. Every time you run a downloaded model, it skips the download and loads it into memory in just a few seconds. Now that the agent is running, let's look at the third example. Example number 3, the OCR extractor. I have a screenshot of a complex purchase order. It has multiple categories, prices, and a specific PO number at the top. I'll go back to the terminal and press Ctrl V to paste the image directly into the chat. Then I add this prompt. Look at this enterprise invoice, calculate the total cost for just the networking and infrastructure section, identify the PO number, and save a breakdown to a file called networkbudget.txt. Because the Gemma 4 model has a built-in vision, it reads the image just like text. It isolates the correct category, does the math, and writes a command to create the new file. I'll just click Y to approve it. To check it, I run the cat command to read the new file. The agent correctly pulled the PO number, ignored the hard drives and shipping fees, and calculated the exact networking subtotal of $997. Now let's look at one final example. Example number 4, the hardware assistant. I copied a standard Raspberry Pi wiring diagram from a web search. I paste it into the terminal and add this prompt. Look at this Raspberry Pi wiring diagram. I am building a self-hosted Pi hole and I need to power a small cooling fan. The fan requires one 5-volt power pin and one ground pin. Find two physical pin numbers that are right next to each other that I can use and write a quick wiring guide to a file called pifansetup.txt. This tests spatial reasoning. The agent must read the labels, map them to the grid, and locate a 5-volt pin directly next to a ground pin. It then writes the command to create the file. I just click yes to approve it and run the cat command to read the result. The agent correctly identified that physical pin 4 and pin 6 are adjacent and provide the exact power needed. And that's how you set up a local AI agent that can read your files, write code, and execute terminal commands. You own the software, and more importantly, you own your data. All the installation commands are in the description, in order and ready to copy paste. If you got stuck anywhere during the setup, leave a comment and I will try to help you out. If this guide saved you time today, leave a like. Check out the videos on the screen right now to see what else you can build with local AI and self-hosting. Thanks for watching.